Today we have scheduled the demonstration and presentation on NanoAcademic technology and its product. NanoAcademic technology is basically was founded in 2008 by Dr. Hongo, Dr. Zhu, Dr. Lee from McGill University, where they developed the software for quantum transports calculations. Around 10 plus years of development, where later on they enhanced their material development through advanced digital techniques and modeling tools, and even they are also addressing emerging quantum computing for spin qubit device application. Quantum technology software, this impulse technology is also representative. We have several unique features and more is in the development. This NanoAcademic technology is based in Montreal, Quebec, Canada, originally from spin-off McGill University. This is about our principle that we are representing. If we talk about the software, how the software journey was started, it was basically started in 2001, where the quantum transport code is NEGF DFT code was patented by Dr. Taylors in 2001. They developed this code NEGF quantum transport with that first, and in 2002 Northwestern University supported with that, and officially the commercial version of this NanoDCAL was launched in 2008. The foundation of NanoAcademic technology was done in 2008 and officially it was released in 2009. So since 2009, the software is working very well. A lot of publications are there that you can find on the Google Scholars. So NanoDCAL is basically a calculation engine that will run the DFT calculations with NEGF, non-equilibrium green function, quantum transport simulations. So all theoretical parameters, background physics equations that will be simulated by using NanoDCAL calculation engine. Apart from that, not only a calculation engine, we have a user interface so that the beginners or new users can learn this software very quickly by playing with the user interface. So that is called Device Studio, where you can model the material structures, manipulate the material structures, make the device structure in quickly. And recently NanoDCAL Plus version has been launched, where a lot of new features, machine learning language has been introduced in that Plus version, where up to 10,000 device simulations atom can be done. Now, in this next slide, if you talk about any NanoDCAL is basically Nano DFT calculator. It is state-of-art NEGF plus DFT code, which is written in MATLAB and C language. And NanoDCAL Plus version is also has been released by NanoAcademic technology, which is written in Python language. So MATLAB, C, Python, all combinations we have, which is used in many of the publications you can find on the Google Scholars. It is main focus on electronics and spin transport calculations, IV characteristics calculations, including the effect of gate, dielectric constants, two-terminal devices, three-terminal devices, four-probe, six-probe device structures, spintronics, collinear, non-collinear, spin-orbit couplings, common analysis like density of state, projected, local density, phonon, band structures, complex. There will be a lot of analysis property will be there. I will show you in the coming slide. We will have a live demo on the tool as well, so that you will get to know how you can model the complicated or simpler structures quickly in the softwares. It main focus on thermal transport, phonon tool calculations. It can plot the energy with band structures, current voltage, conductance, thermoelectric, modulars, and many more properties. If you want to make some terminal, electrode terminals, right, boundary condition terminals, and you can apply the gate voltage biasings. So that two terminal, three terminal device can be simulated. Along with that, it can work in molecular junctions, molecular spintronics device simulations, all kind of electrodes, any material you can use to make your device. Now, this software is dedicatedly designed to design the materials and the devices at nanoscale range. Either you want to simulate the molecules, graphene on molecules, or any other molecular structures, or molecular based device structures can be simulated. It can simulate the surface, where you can define some Miller indices and surface plane conditions. So all surface positions, complex material, hexagonals, boron nitride, tetragonal, triclinic, orthorhombic, all kind of complex materials you can simulate. Two-dimensional material based device structure, MOS2 based device structure, or GNR-FET based device structures. Any material based device structure, including 2D material, can be simulated. It can work on an interface also. If you want to make a interface heterostructures, then it is also possible on different materials. On you can find the lattice matching, mismatchings, and find the interface properties. And all carbon-based material and different other material type you can use in the software, and it can be work in that platform. Now, in this next slide, this software having advanced tool to build your structures. All crystal maker are there, designing tools are there where you can design your structures. You can set user friendly setup calculations parameters are there, where in the user interface you can mention the DFT parameters, exchange correlation functions, pseudo potentials, basis sets, couplings, and spin orbit type effect and key point sampling, and many more setup calculation parameter can be defined simply in the user friendly interface. And visualization is also there. You can visualize your output and you can export your raw data in a standard format. The raw data can be exported. So mostly all material property, including the electronic, structural, optical, thermal, magnetic, electronic, thermal transport, electron phonon couplings, these all material property can be calculated. Apart from that, device property is there that can also calculate, like current voltage curve, transmission coefficient, and photocurrent analysis, modulus, thermoelectric currents, and many more property will be displayed that you can calculate quickly using this software. This software, NanoDCAL, can also NanoDCAL and NanoDCAL Plus version can work in all domain, not only in nanoelectronics material or devices. It can also work on spintronics, spin up, spin down calculations, movement of spins, rotations of spin atoms, rotations, or any polarizations, whatever you want to simulate, or whatever intrinsic magnetic movements, or including the photocurrent effect. You can also do the study by defining some polarization, elliptical, vertical, horizontal polarizations, electromagnetic waves you can apply on this your device regions, and you can study the spin effect on the device characteristics. This software can also work on energy storage devices, photogalvanic, spintronics, solar cells, and even batteries applications can also be done. Single layer, mono layer, bi-layer, tri-layers, any number of layers you can design. Like here there are 3 layers are there parallel to each other, boron nitride, graphenes, and boron nitride, where left circle is called left one is called left electrode, and this is right electrode, and middle one is called scattering central channel regions. And you can apply the Wissing either on left electrode, right electrode, spin up, spin downs, and you can find the EK diagrams with respect to direct band gap, indirect band gap, or any other doping, different kind of dopings. You can introduce some structural defects, some atomic defects, delete the atoms, create a new atoms. A lot of type of doping, mixture dopings, atomic dopings can be included, and you can find some all type of characteristics can be created and simulated. Now this is a presentation only where it will concentrate what kind of features can be done or using this software can be simulated. We will have a live demo shortly where you will get to know how it can be modeled in the software. This NanoDCAL can also work on molecular electronics application, where there is a molecules is there in between the electrode. So you can define the electrode, left electrode, right electrode, up to 6 probe boundary conditions you can specify, and you can set the electrode and define the channel scattering, molecular junctions, molecular benzenes, or any other alkylthiols, or any molecules you can take between the electrodes, and you can apply some gate voltage in that gate regions, and you can find the IDVD and IGVG characteristics and transmission coefficients, photocurrent, and other property can be calculated. This software can also work in graphene electronics applications as well, where you can find the direct band gap, indirect band gap, stability of the seeds, Brilliant Jones root points, band structures on different positions. You can rotate certain atoms or replace the atom with different other dopings or delete the atoms. So any type of surface, Miller indices, lattice mismatching, adsorptions, bonding, non-bonding, lattice bond range, bond length you can adjust and manipulate as per your needs. You can find the band structure on different billion Jones root points on different surface structures and plot the PDOS and other characteristics. Now, if you want to work on mesoscopic electron transport property in twisted bilayer graphene, suppose you have a graphene sheets, that sheet you want to twist on particular angle, left, right, or any particular radius, particular angle, degree, theta, you can specify either left side, right side. By twisting the graphene sheets, what will be the effect on this output characteristics? That can be studied, and you can do this performance and introducing the dopings or various other manipulations. Once you will do it, then you can do different scenarios and you can simulate your nanostructures. Even nanowires, graphenes, carbon nanotubes, all applications can be simulated. This NanoDCAL is fully based on LCAO, linear combination of atomic orbital, LCAO based DFT plus NEGF quantum transports calculations for 2-terminal, 6-terminal, 4-terminal device application. Like you can define the top electrode boundary condition, bottom side boundary condition, left side, right side, front side, back sides, wherever your electrode regions is there, that location you can specify the electrode and you can find the IDVD and other characteristics, and including the conductance, thermoelectrics, and other electrical mechanical parameters you can calculate very easily. Now this is a small presentation that I wanted to show you here. So here the NanoDCAL, this NanoAcademic technology is very world class. They have a good number of nanoelectronics physicists, advanced applied computing physicists and experts developing atomistics, and quantum simulation tool is also there for advanced application for spin qubit devices. New features, new software has been developed in another software, not this one. This is specifically for small nanomaterial and quantum transport NEGF device calculations. The feature of this software are very rich and unique. Quantum solvers predict material properties, save manufacturing time, fast convergence in non-linear multi-scale solver for large number of atoms, powerful features including the machine learning in NanoDCAL Plus, efficient and parallel scalable design flow. Tutorials are there to start quickly. Open source integrate Python API integration with third-party tools. If you want to integrate with a third-party BAS, Quantum Expresso, NewChem, LAMPS, all third-party interface, free trial version, easy installation, license activation, 1 year free updates, all things can be provided. This is NanoDCAL that we discussed in the presentation. We have another software that is called Rescue for real space electronic structure calculations. Rescue is a different software from the same company that will work on DFT plus DFPT, density functional theory, and density functional perturbation theory. So DFPT is also implemented in Rescue that will work on energy storage, large number of atoms, Raman spectra calculations, optical property calculations. In that case, Rescue another software. I will show you some PPT as well for these software as well, so that you will get to know. Now, this is my contact information. If any person required any more details of this tool, then we can have a separate webinar in your institute. Live webinar we can arrange. So if anybody want to arrange live webinar for their institute, kindly invite us on the email or on the call, so that we can have a more webinar in the future and we can technically satisfy you in terms of capability of the tools. So thank you for listening to all the participants. This is a small brief introduction about NanoAcademic technology. Now I would like to demonstrate you live in this software that how you can import the materials, design the materials, manipulate the structures, define various parameters, DFT parameters, and some applying of voltage visings and analysis of results that will be demonstrated from now. So thank you for your times to listening these presentations. Now I would like to start from scratch. So I will click create a new project. I click on OK. Here suppose I can save the project on my desktop. So I suppose I give the name of my project as a text and I can click on save. Now I can maximize my user interface device studio. Now this is a user interface that I will show you how to model the structures. Now first of all I can click on file where I can create a new project, open my existing projects, I can save the projects, I can make the new device structures, I can make the new crystal structure, molecule structures. So directly we can make a new crystal, we can create our new crystal. We have a lattice space group information where 1p1, 2p1 or 3p2, 4p21, 5c2. Accordingly, it will select the monoclinic, simple cubic, FCC, BCC, rhombohedral, orthorhombic or BCC type, whatever from this space group you will select. Accordingly, Brevis lattice type will be selected. Here you can see the ABC value is there. You can change this ABC value. Whatever ABC value you want to take it, you can take accordingly. And B by A and C by A and alpha, beta, gamma will be automatically adjusted. You can select the fractional coordinate points wherever the location of your coordinate points. And now by default fractional coordinate point P1, P2, P3 is selected with the element is equal to carbon. If you want to use different material, you can use whatever material you want to take it. You can select from the periodic table and click on open and see the primitive cell preview styles. You can see the preview before build this structure. You can click to see the preview and you can see the conventional cells and primitive cells. All options are there. Whatever kind of cells you want to visualize, you can see, then you can build here. So new material or new crystal you can make by these options. So what you have to do, you can click on file and new, and here this is a crystal maker. This is a molecular builder where you can build the molecule by simply putting this molecule here. Like if you want to make a H2O molecule, simply you can select this H2O from here. Like that you can change from periodic table. It's a molecular builder and define the value XYZ positions of your molecules. It will adjust the molecular builders like that. You can see the preview. Like this is H2O. There are 2 hydrogen atom and 1 oxygen atom. Once we will define this XYZ coordinate point properly, then the bond length can be adjusted very easily. So anything you can define your value as per your needs and you can adjust this H2O molecule as per your requirements. It is basically a molecular builder that you can build here like that. Now I want to delete it first. It's basically to create a new material. So new crystal, new molecule or new device can directly create in the software, but I want to import from my database. So we have a 2 option to import the material. One is called import local, that is local library, local database of the software. So I can click on import local. We have an import online option as well. If you want to import from material projects, open source database, crystallographic open source database or any other open source database, through the API access, it will make the interface through the third-party software and you can search the material by clicking on import online. If you want to search MOS2, suppose online, you can click on this and it will search the new material online. Like I type MOS2 2D material, it has given all combination from open source material database through the API search interface. It will search the new material by online. Then we can select the particular material and click on add button to add in our dashboard. It is now added. We can zoom that particular regions. Now I have zoomed that crystal. Now I can draw the rectangle. I can draw the rectangle and I can delete the undesired atom like that. Similarly, if I want to delete these atoms, I can draw the rectangle and I can again, or I can click on particular atom and press control, long press control, then select the atom which I want to delete it. Now this atom has deleted. There are a lot of vacuums are there in this unit cell. If I want to remove this vacuum, in that case you can click on this convert to crystal option. Once you will click on convert to crystal, there is huge vacuum in C direction. That C direction we can minimize this thickness of C direction. You can see I have reduced this C direction vacuum. I have reduced it, and similarly I can click, if I want to reduce more, I can click like that. It will reduce more value like that. Now I want to adjust my this atom in center. So I will select it to press control and go to this center option. Along A I can press along C direction. I can make it center. 1 minute. It is now in center position of this. Now this is simple material MOS2 that I have imported from online search database. Anybody can search online material like that. If I want to simulate this simple material, I will go to the simulator, and in the simulator multiple options are there. NanoDCAL, the software that we have scheduled the demonstration today. Apart from that, for large scale DFT plus DFPT, we have a rescue software. Even this NanoDCAL device studio can also make the interface for WASP, LAMPS, Quantum Expresso, Gaussian, NewShape. All third-party tool interface is there. If any doubt will be there, we will have a query session after this webinar, so that you can also ask your questions after this webinar as well. Now in this NanoDCAL, I select it and click on SCF calculations. Here I need to define the electron temperature, at what temperature I want to work, energy cutoff range. I can adjust as per my needs, different exchange correlation functions, LDA, GGA, PB functionals are there, and K point samplings are there. We have to adjust this K point, number of K point in N1, N2, N3 direction. And similarly, I have to define some Hamiltonian density matrix parameters, some iteration control parameters that we need to adjust. We have to simulate this Hamiltonian first. Then we have to go to this basis sets, double zeta polarized or single zeta polarized, double zeta double polarized, or user defined basis sets is also possible. We have a library of atomic database. Neutral atomic database library is there, where all basis sets are available in our library. For all materials, all type of basis sets are there that you can upload from our existing library. So this is called all material, mostly you can find. There are 3 folders are there. This is one folder where mostly you can find the neutral atomic database, and particular material wise all folders are there, where LDA type, GGA type, and other type of for crystal, bulk, all type of database, neutral atomic database, basis set database is there that you can upload. It is also having Hubbard U terms, LDA plus U, where SPDF value you can define this SPDF position. So Hubbard U terms is also there. Spin type, if you want to include the spin, spintronics application, collinear spin, general spins, non-collinear spin, orbit coupling, spin polarizations, spin orbit couplings. So it is also there. All spintronics applications can also be simulated. I want to take a default parameter. So I click on generate file. I click on it that will generate this folder. Now this SCF file has generated in this crystal folder, where if you want to check the background script, you can right click and click on open. So the script that is automatically generated from the user interface, you can also check this script as well. What type of calculation, SCF parameters, energy cutoff, action correlation functions, k-point samplings, and vector parameters or iteration control parameters, or whatever this coordinate points of molybdenum and sulfide, that all coordinate points are there, XYZ coordinate points. So this is basically showing the all script that is auto generated. Now I would like to run the calculation for this simple MOS2. I right click and click on run button to run the program. Here I can define the number of parallel cores if you want to run the job in parallel. Suppose 5 number of core, 10 core, 15 core, 16 core. Since in my computer 8 cores are there maximum, that's why it is showing 8 core. But no limitation is there. You can define up to 128 cores easily. I can click on run button to run the program. On the bottom of the page, there is a job manager page is there, where the calculation got started to running the program. So let it run the program. In the meantime, I can select the analysis type. What type of analysis or plot you want to get for this material. So I go to this NanoDCAL and click on analysis option. These are my property. Simulation for this SCF input file is running in the background, that you can see in the status that is running showing. Now here you need to select, if you want to see a band structure, you have to select it. If you want to see electron density, potential, transmission channel, eigenstates, complex band structure, ZT, unknown modulus, and charge, effector potentials, density of states, whatever you want to plot, from these analysis input file of material. It is not for device, it is for material. So whatever property you want to calculate, you can select from this option. I have selected 8 property from this selected output. Now these are some symmetry, k-point, billion zones, root points. You can adjust the band structures, billion zones, root point, add or delete certain billion zones, root point according to your needs. And you can adjust and see the preview and set apply. Number of key points in the billion zones root point you can apply, and then you can click on generate files. Now my calculation of SCF input file, you can see the calculation is finished for this SCF input file. Now I have selected 8 analysis input file. We have to run all these input file as well. Band structure dot input file. I right click and click on run program and run this program. Similarly, I will click on all this one by one. So automatically it in the queue condition. Queue condition means once one will finish the calculation, next program will automatically start executing. That's why I am putting here all this analysis input file to run. Now I can click on run button. Here you can see the calculation are getting finished quickly. It is getting finished and other are in the queue condition. Automatically it will start the program. Once this finish the calculation, next program, next analysis input file will start the execution automatically. Parallelly, you can see the output for all input file are, as suppose the first input file, analysis input file, finish the calculation. The band structure file has generated. Second one, electron density, has finished the calculation. The analysis input file, output file has generated. So output file will also parallelly generate one by one. Once get finished the calculation, output will generate. Then next will start and it will output will generate, and then again next input file will run the program and output will be generated simultaneously. I can click on band structure so view. Now this is band structure without any spin. If you will include the spin up, spin down polarization, then with the spin and without spin, it can display the graph with that property. Now this is for MOS2 that I have, you can see here. You can see the top from middle of valence band, conduction band, like that. If you want to export your data, you can click on export button. You can export your data in the form of PNG, JPG, PDF, Excel, TIFF format, text format. If you want to export in text format or any format, whatever you can see in this screen, it can export your data. And click on save button. Now your data for this band structure has been saved on the desktop. Now you can see this is a raw data that is of band structure that is exported from the graph. So any output, if you want to export, it can be easily exported. Similarly, if you want to see some other property, total electron density, this is total electron density 3D plot where 3D viewer option is there, x by z, zx, by x, zx, whatever planes you want to see this view. You can see in any view, including the 2D model, two-dimensional plots you can also visualize. This is total electron density in two-dimensional structure along x-axis, along y-axis, along z-axis. All average direction you can plot with planar display and stereoscopic display. All plots can be visualized. Like this is a stereoscopic display of total electron density. You can also export this image in the form of line or any other shape you want to export. It can be easily exported like that. So 2D models, 3D models as well as Bundy output. This is one dimensional plot of total electron density in xy, yz and xz. Any planes you can see the output. Similarly, other effective potential, if you want to see the effective potential, this is 3D model of electric potential. And you can see the 2D plot. This is 2D plot effective potential. You can zoom particular regions like that. And Bundy plots. Bundy, 2D, 3D, all plots are possible in all options. Like whatever the direction you want to see, it can be plotted like that. And you can export this image in the form of PNG, PDF, text or whatever image format you want to save, you can save it easily. And similarly, other property are there. Transmission channel, if you want to see, this is a transmission channel with energy range from -5 to 5 energy range. It is showing the number of channels, regions, eigenstates, complex band structure and other. This is eigenstates in 3D model. And this is eigenstate graph and one-dimensional model. So 1D, 2D, 3D, all are there with the complex band structure. This is complex real and imaginary parts of complex band structure. Red one is called real and imaginary one is called blue. We can plot these and density of states if you want to see. There is certain parameters are not defined. That's why the plot is not showing. It is not showing properly. Now this is a way where you can simulate any material. Now I want to make a device structure here. So what I do, I click on file option, then click on import option. I can click on import local. Local means local library of material. So you can see in this device studio folder inside C drive, material folder is there. Where 0-dimensional material, that is molecules are there, amorphous type, crystalline type, polystyrene, polyethylene, all crystalline material database. This is a material database. So 0-dimensional molecule material, crystalline, amorphous, 1-dimensional, 2-dimensional, 3-dimensional, conductor, insulator, metallic material, all materials will be there. Like this is a crystalline material. If you would like to go for 1-dimensional carbon nanotube material, this is a different chiral vector, multiple combination of carbon nanotube with different n and m value according to that 5, 5, 6, 6, 7, 0. This is different chiral vector, 1-dimensional molecule material and 2D material molecules are there like nobility, arsenide, bismuth, black phosphorus, hexagonal boron nitride or graphene material is also there. This is graphenes. And we talk about 3D material. This is conductor, insulator, layer material, metal oxide, magnetic material, nobility material, semiconductors. This is a material database. Our conclusion is that it is a material database where all type of materials are exist in the library. I can click on, suppose I go to this conductor and pure metal I can select here. I can select suppose gold from here, and here you can see HZW, XYZ, CIF, SIF file, XSD, postcard file, SCF.input, relax.j. These file format directly upload. Suppose you have a gold in SIF file or in XYZ file or HZW file or XSD file, directly you can upload. If you have any other format, you can also convert that format in this device studio. So device studio is not only direct import, it can convert your existing format which is compatible with this device studio. So I have a one convert option that I will show you in coming time, that you will see how you can convert your existing projects and upload in this device studio and run the simulation and compare your results with the existing software and this NanoDCAL device studio. I have selected this gold and click on open it. Now this gold has been opened. Now the gold has opened here. You can see this is my gold that I have imported from my material library. Now I can go to this builder option where I can build my structure as per my requirements. Multiple builder options are there. You can make the device, you can convert your material to device, bending of device will be possible once you created the device, interface builder between different two material, at CAD design modeling, CAD drawing modeling, crystal maker, redefine the crystal size positions, surface lab, symmetry of operations, molecule decomposition, graphene nanoribbon, graphene nanotube, grain boundary, nanotube, nanowire, disordered, octohedron bond option, and convert file. If you want to convert your existing file, it can convert in XYZ or SIF file that you can upload here in the software. I want to redefine my crystal, so I will click on redefine this crystal. Here I can define the crystal express the new cell vector UVW as a linear combination of the current cell vector. I can select face centered. By default ABC value has been changed. I can see the preview. Once I select this face centered, this is a preview of this my unit cell of gold. This is my preview. I can click on build button. Once I click on build button, it is now added in my dashboards. I can adjust as per my needs. Now here I can go to the home option and click on X by or main home screen. Now I want to repeat my structure, so I will go again to the builder and click on redefine crystal. Now I want to repeat in ABC direction. In A direction, that is called G direction, I want to repeat 2 times. In vertical direction, I want to repeat 2 times. And in C direction, that is horizontal direction, I want to repeat 4 times. I can see the preview. This is my preview before create or build. Now I can build it here. This is my build. I can go to this home screen and see the X by. Now I want to delete undesired atom, so I can draw the rectangle like that to select my desired atom by yellow color, dark yellow color, it will get selected. I can click on press delete atom, where undesired atom I can select and delete like that. I can click and delete it in this manner. And you can see the ZX view also. This is X by Z, ZX by X, which view you can see any plane view. And if I want to delete some more atom, I can simply delete these atoms as well. These 1, 2, 3, 4, 5. These atom I want to delete it. Now it is deleted the atoms here. Now if you want to make a symmetrical device in suppose in NMOS or any other 2-terminal device, you want to make it symmetrical, then you can make such type of device structures. If you want to create a vacuum, Then you can click on convert to crystal. Once you click on it, here you can define the vacuum you can include in A direction. Suppose you want to define vacuum 20. So A is called G direction. I have defined 20 from 8. Now you can see there is a vacuum is created in this A direction. That is called A direction where vacuum is created. Similarly, I want to create a vacuum in B direction. That is vertical direction. I want to include some more vacuum. I simply select here and define my vacuum value. Now you can see the back and then click on apply. Now you can see the symmetrical device, the left and right electrode symmetrical device has created. Now I can increase the vacuum here or I can make it center. I can draw the rectangle and make it center, this one in A and C direction. A and B direction I can make it center along B axis. It is now in the center positions. Then I can go to this, again convert to crystal. Now I can change this thickness. Vacuum I can change here. Now you can see this both left and right electrode, gold electrode in the same unit cell has been created. And then I can click on build button. Now it is in the both in the same position. Now if you want to make a molecular junction based device, I can import a new molecule here. So I go to the import and import local. I will find my molecule, whatever molecule I want to create or upload. Suppose I take alkyl, I selected it, I draw the rectangle and right click to copy it, and then I will paste to my previous defined material. Here I can paste it like that. It is now pasted. I can select it and then I can make it in the center. 1 minute. I can press center. Now it is has been reached that molecule in the center position between the electrodes. Now you can see this is a, now we will convert this into the device. In middle region is called molecule and kinethyl molecule. Left and right is called gold electrode. Now I want to convert into the device. So I will click on convert to device option. I can define the left electrode, right electrode, whatever positions, Z positions we can define, adjust. By default it will take, but if you want to adjust something, you can adjust as per your needs. So it is added how much electrode thickness you want to apply. You can, according to your needs, you can adjust. So left electrode, right electrode, front, top, bottom, back electrode, any up to 6 probe device structure you can create. Then click on build option to create the device structure. Now you can see the device has created where left and right electrode is there. Left is called, it is symmetrical device. Left and right electrode is called gold. But if you want to change one electrode should be a different material, then what you need to do, draw the rectangle like that. This is all electrode. This one is called phosphorus. And if you want to change the atom with different other material, you can click on replace atom. If you want to use different aluminum instead of gold, or you want to use a silver, so from periodic table, which metallic material you want to use for your left or right side electrode, you can select from that. If you want to use silver, you can use AG and click OK. Now left side is having different electrode and right side is having different material based electrode. Now your 2-terminal device is ready, that you can simulate using the software. Now once it is ready, then you can go to the simulator, and in NanoDCAL there is a transistors option is there. If you want to simulate a 3-terminal device where a gate is also there, then you can define the transistors and select the gate region, the special region. You can select the permittivity, whatever the permittivity value is there, that you can mention, and thickness of your gate regions you can define like that. The gate region thickness, transparent, and gray color is called your regions in middle of this gate. If you want to apply different biasing of gate voltage, like here 0.1, 0.2, 0.3 is applying, but if you want to apply 1 volt, 1.2 volt, and 1.5 volt or 2.0 volt, so you can adjust, or whatever voltage biasing you want to apply, that can be applied. You can define either top electrode, bottom gate region, front or back side gate region, where the region of gate, the location you can specify, and the regions can also be specified in whole middle scattering region, or there is some limited scattering region the gate is there, that you have to mention. And accordingly this gray lines that you can see on the top of that will be adjusted as per the mentioned value provided by you. The gate region is increasing, whatever we want to define the value. And this is a transistor source or drain you can mention, either in the left side or right side, and BD value you can define as per your needs, whatever the BD value is there, either 0.5, 1, 1.0, 1.5, multiple you can apply, and according to the varying of gate voltage or varying of a source drain voltage, how the characteristics will be changed, that can be studied. I can click on generate file. So now you can see the multiple files has got generated on different gate voltage and different drain voltage. So first of all, it is at equilibrium condition. The first we will call is device scattering central region, SCF.input file, left electrode SCF.input file, right electrode SCF.input file. Then VD equal to 0 and VG equal to 0. VD equal to 0.5, VG equal to 1 volts, and it is like simulating by fixed drain voltage, gate voltage is varying, changing, then drain voltage is fixed and gate voltage is changing, drain voltage is varying. That's why multiple files are there. We can run all files in queue conditions. Once one gets finished the calculation, next one will start the program executing automatically. So since the device will take time, you can see some device other parameter. Like if you want to see, this is a device parameter, you can define the left electrode temperature, left electrode voltage, right electrode temperature. Both sides it will be possible. So SCF calculation for device is also there. And if you talk about analysis for the device, you can see this analysis type. Earlier I show you the analysis for crystal, for material, bulk material. But if you want to study for device region, then you can see this is density of state for device, projected density of state, or some effective potential, total energy, plots, scattering, transmission, photocurrent, IV curve, charge, electron density, potential, conductance, thermoelectric, Seebeck coefficients. Whatever property you want to calculate, that you have to select from here. And effective potential, Hardy potential, exchange correlation potentials, neutral atomic potential. These are the device property that you can plot. You can also irradiate your atoms. If you want to put a light on your device, then you can also irradiate the regions, wherever which region you want to fall your lights. So you have to select it, that particular regions, and select the atomic indices, and you can apply it. So atom irradiations can be possible. You have to generate the files, and these are all analysis input file will be generated accordingly. So this is an example. Now I can take one interface as well, that how we can create. I can click import one silver atom as well, silver metallic material. Gold is already there. I want to make interface between gold and silver. And what I have to do, I have selected this silver regions, and this is a gold material. This one is called silver. If you want to make the interface in any material, as an example, I have taken this silver and gold. I will go to the builder, and here I can click on interface builder. I can select the silver and gold from my project window. So gold is now selected, and now I selected the silver. I can repeat number of times in n times. You can repeat and find the matching. And you can see the preview, strain stress on first second surface, which surface you want to see the strain stress effects. So that kind of study you can perform and see the preview. Or on the both surface, first surface strain stress effects can be studied. So it is like interface between gold and silver that is created in very short period of times. And I can click on build. Now it's builded in our dashboard's background, black background regions. So this is just interface in between gold and silver. So heterostructure interface can be created either nickel graphenes or Fe MgO, Fe magnetic tunnel junctions, left right electrodes scattering region interface. You can create it very quickly. If you want to change the device, you want to bend the device on particular angle, bending of device is possible. You can bend left side, right side on particular angle. Like this is a bending of device. If you want to bend it, you can bend on particular either single side, both side. You can bend the preview. And if you want to make a silver surface structures, like this is a surface slab. If you want to make surface 1 0 0 0 0 0 1 1 1, whatever Miller indices of surface you want to define, you can create the vacuum, thickness, slabs, all options are there. If you want to make 1 0 0, this is surface, and 1 1 1, like that plane study you can perform, which plane 0 1 1 or any plane you can work in that. And if you want to create a vacuum, you have to activate the slabs and define the thickness, like number of times you can repeat to increase the thickness, and vacuum also. Vacuum in the regions you can include and see the preview if you want to include as well. And this is surface slab, and click on build button, it will build. This is a AG 100 project that has got generated. Now if you want to make, other options are there. You can see graphene nanoribbon, graphene nanotube, grain boundary, nanotube, nanowire, disordered shapes. All options will be helpful to design your complicated structures. You can measure, the distance measurement tool is there in the right side. Distance between one atom to another atom. If you want to measure the distance from this atom to this atom, this is from center to center, it will measure the distance like 2.889. This is center to center distance measurements. If you want to measure the bond length, you can draw the rectangle to select the atoms. And this is a bond length between silver atoms. This is a distance is displaying. You can change the bond length, theta. You can measure not only distance, you can measure the angle as well in between three atoms. Angle measurements, plane measurements, dihedral measurements, plane to plane dihedral measurements, and vector measurements between two atoms. Linker bond calculates, and we can make it convert to crystal, convert to device, convert to molecules, create a mirror, rotate, delete, change the atoms. All options will be helpful. And if you want to make it some Nanoribbon, you can click on Graphene Nanoribbon. Here you can select the unit cell of Nanoribbon by the chiral vector N and M, side A and side B. If you want to change boron based, carbon based, or any other from periodic table, you can select it and click on it, or you can select carbon, whatever you want to choose the material. Bond length you can specify, passivate with the dangling bonds. You can define the N and M chiral vectors, zigzag, armchair, zigzag, whatever type of graphene. This is like graphene. If you want to save by different N and M value, it's like will be created boron based material. If you want to save carbon, you can select this carbon and similarly select the carbon from here. Click OK and see the preview. And this is a carbon that I can rotate it here and click on build button. Now it is rotated. Here you can see it is my rotated structures. This is single seats. If you want to make it copy, multiple seats can be created very easily. Like you can select it by drawing the rectangle. The yellow color gets selected. Then you can press Ctrl C and press Ctrl B. And you can press this and you can change its position upside or downside, wherever you want to change. It can be adjusted. You can select this move button. It can move like that. It is adjusted basically in that, but it is same way. It can be created very easily. There is not a very complicated task. Multi-layered structures you can simulate. You can make it undo this one. If you want to delete certain undesired atom, then simply you can select the particular atom and press delete button to delete it. It will be deleted from that particular location to create the defect. Now defect is created in the seats like that. So either you can select it or you can select the rectangle. Which atom you want to select, accordingly you have to draw the rectangle, and then you can rotate, or you can create a mirrors, or you can rotate particular angles, move the atoms, rotate the angles clockwise, anti-clockwise with particular angle, 30 degree, 40 degree, whatever angle rotation. And you can also move the atoms in any x by z, whatever positions you want to move. Or if you want to replace it, this carbon atom with magnesium or any other doping you want to introduce, you can introduce the doping like that. It will be introduced. So gray color is called carbon atom and white is called hydrogen passivation on the boundary condition, and blue one is called magnesium. This left side is called a project window, where all input file, output file will be displayed in this project window. And bottom side, this is called property window, where it will display the property of a unit cell or device or material or molecule, whatever the material selected in your dashboard. This background, black background region, the information about that, how many total number of atoms, total area of the lattice, vector ABC, coordinate points, that will be displayed to you, so that you will have a complete proper knowledge about the tool. If you want to work on other application like nanowire, this is nanowire 1001111, cluster radius, surface energy in 100, and different whatever the bias direction you want to define. See the preview, and you can create the wire. Nanowire can be created like that. And there are some other nanotube. If you want to create a nanotube, this is for nanotube builder. You can define the chiral vector. 1 minute. This is for nanotube. You can see this nanotube can be built. Like this is nanotube for silver has been taken, but I can select all atom. I can select it and change the atoms from the periodic table. Now all are carbon atoms. You can see it is displaying the XYZ coordinate point or particular selected atom. Whatever I will click on it, it will display the information. And once you click on background, it will display how many atoms and other things are there. Multi-ball, multi-structures can be created easily. And these are certain other options are there. If you want to make it some grain boundaries, nanotube, disordered graphenes. This is grain boundary where different positions are grain boundary conditions. HKL value you can define it, and you can see the preview for the grain boundary regions. Now this is basically all modeling tools that will help you to model your structures. If you want to say disordered, say graphene supercell, you can see a disordered waist as well. Bond lengths and different atoms for the graphenes you can select from periodic table. So this will user interface will help you a lot, and even though it is not an interface, it is also having calculation tool. So NanoDCAL, where you can include the buffer, SCF calculations, transistors, analysis plots, relaxation. You can also relax your structure by using MD, molecular dynamics and conjugated gradients. You can relax your electrode. There is some other software interfaces there. If we talk about this software can work as a interface for quantum X ratio as well. Like this is quantum X ratio input file that can generate by using this software. All exchange correlation functions, whatever they are in quantum X ratio, that is showing here. Iteration control parameters, basis sets and spin type. We can click on generate file, scf.input file with their flags, control flag, system flag, electron flags. This is quantum X ratio input file that will generate in a seconds by using this device studio. Similarly, not only for quantum X ratio, it can also work for LAMPS interface, for Gaussian, for WASP, for NewChem. Like this is for Gaussian. I can click on generate file and Gaussian.com file input file will be generated. And similarly for WASP and LAMPS, it can generate the various parameters. Now, so basically this software will be helpful. Now I would like to show you some results from my existing projects so that you will see some output as well. Like suppose this is my earlier device. Since simulation takes some time, but we have a shortage of time, so I want to show you some graphs for my existing projects. Like this is one device where H2O is there on top of this graphene sheets and some different colors with different atoms are displaying. Like this red color is called oxygen, this gray color is called carbon, this one is called white, white one is called hydrogen, and this one is called boron, and this is called potassium, sulfur. So this is all different atoms will be here where left and right electrodes are there. I have simulated this structure in past, so I can show you some characteristics property. If we want to see a density of states, so from -10 to 10 electron volt, density of state plots is there. We can export the raw data in PNG, JPG, PDF, all standard format, your data can be exported. So this is density of state. Similarly, if you want to see some other characteristics like total electron density potentials, this is total electron density in all direction, you can see. Like that. And effective potential and other Seebeck coefficients, like this is effective potential in scattering regions, only scattering region effective potential is showing. And this is a two-dimensional model and x y z location and 1D models. And Seebeck coefficient, if you want to see a Seebeck coefficient, this is Seebeck coefficient, chemical potentials, spin up, spin down, Seebeck coefficient, chemical potentials, like that. And different temperature, all temperature value, it will plot the graph. You can judge at what output you want to see your characteristics. It will show the graph on particular that value. So Seebeck spins and Seebeck charges. Red one is called Seebeck charge. Other one is called, blue one is called Seebeck spin. If we include the spin effect, then spintronics can also be visualized. And similarly, not only, even transistors characteristics can also be visualized. We want to see a device property, transistors plots, even it can plot the IV characteristics as well on different voltage. Like this is one output transfer characteristics where IDVG, IDVD characteristics will be plotted. And this is VD graph on different gate voltage. It is not fully simulated, this structure I was trying to simulate, but on all different value of gate voltage, transfer characteristics can be plotted easily. So this is all about this tool information. And Rescue is another software for real space electronic structure calculation, that is basically for batteries, energy storage device, density functional perturbation theories, Raman spectra, optical property, phonon calculations with exchange correlation functions of LDA, GGA, meta GGA, real space and LCO, linear combination of atomic orbitals, all are there. Like Raman property, Raman tab is there, incoming photon polarization, outcome photon polarization, and their optical property can be calculated. This is a new tool basically. And similarly, in this rescue, you can perform all SCF calculations with LCO and all exchange correlation functions, LDA, GGA, GGA with meta GGA, hybrid GGA, hybrid functionals are there, P3L by P, HSC06. This is exchange correlation functions for hybrid functions and all basis sets, and their spin type is there. Now, this is all about NanoDCAL and rescue. If we talk about this is NanoAcademic.com websites where you can visit this NanoAcademic.com. You can find a lot of more information about this software on this website so that you can go through it, and if question will be remaining, then we will have a live demo in future as well. Like this is a technical papers you can find in this technical insight. Papers published using this software. Product you can select NanoDCAL and from which year it was. From 2010 you can find a lot of papers has been published. The publication list is very broad that you can see. This is all publication list. Drop down menu is there. More publication paper you can find on the Google Scholar page. These all are publication using this software. If we want to see the documentation page, we have a portal as well. This is NanoAcademic documentation page for NanoDCAL, rescue, and quantum TCAD, quantum technology software for spin qubit device application, QTCAD. You can click on particular options and see the tutorial. These are different tutorial that is created more is being updating. So once you find this more update is going on, so you can visit any tutorial and you can find step by step details description how you can model the structure and simulate any complicated nanomaterial nano device using this device studio NanoDCAL software. So from my side, thank you to all the participants for listening this webinar presentation and demonstration very carefully, and thank you for your patience. And if you have any questions, if any participant joined late or have doubt any, then you can drop email, you can contact us on our email ID and mobile number. This is my email ID. Either you can keep in touch with my colleague Ravi Kant or me or Mr. Deepak. So thank you for listening and giving your time. Now you can ask your query, you can unmute your mic and you can ask your queries one by one, please. You can type your queries in the chat box as well. If somebody wants to type on chat box, please type and I will be here to help you to answer your questions. Now, one of the participants, Dr. S. Vidya, asking about what is the pricing of the software. Basically, this is a commercial software that need to be purchased. It is not a free software. And the pricing will be depend on the requirement. Like we have a single license, 2 licenses, 5 licenses, 1 year, 3 year, permanent. So 2 lakhs, the pricing will start, and up to 15 lakh to 14 lakh it will goes. But 1 license permanent will cost around 6 to 7 lakhs. So in between 6 to 7 lakhs, 1 permanent perpetual license can be given. So it required good computational powers. Good workstation is definitely required to simulate the device structures. As much as your computer is good, you will get the faster calculation speed. Any other participants have any questions, then kindly ask, please. Yes, the band structures, definitely you can compare the results with your band structure and other parameter with BAS. I can show you, there is one PPT where the results were compared in rescue. Like I can show you this one minute. BAS comparison with rescue, and quantum ATK will compare with NanoDCAL. VAS is only DFT, there is no device simulation feature. IB curve cannot be calculated using device. These are some parameter property that we have calculated and compared with VAS and rescue. Lattice constant is calculated, and this is a results. Rescue with PVU elements for particular element, rescue, VAS and experimental. This is a huge slide. Magnetic moment we have compared for VAS, rescue. You can see these are different on different angles. This magnetic moment were compared, lattice constants on HSC. This is a physical review papers is also there. In that, this results with BASP and this rescue is compared. You can see red graph and blue dots are there, where approximately you will get comparable results with BASP and rescue. So rescue software is useful for material, large scale material DFT plus DFPT calculations. This is some other dielectric constant parameter DFPT calculation, rescue, BASP and experimental. Ion clamped static dark constant, dielectric constants. So I can share this PPT to you if somebody wants and see how it can be. See, these results are very close to the BASF and other experimental papers. Even results can also be matched with quantum X ratio. And these are some core number of course calculation speeds. parallel efficiency speed. Thank you very much and giving your time to listening this